All right, I'm going to go ahead and start recording. Going forward, do not email me any assignments. Any assignments emailed to me will not be graded. So make sure everything is submitted via Blackboard. And this week, I will be posting there's two GAs assigned to the course for RAs. I will post their information or tell them to contact you guys. Additionally, we will set office hours for all three of us to work through the entire week. So somebody will get one half of the week, someone get the other half, and they'll be physically on campus. But you don't necessarily have to come on campus. You will be meeting with, they'll give out a Zoom link, not or a Google Meet link, and they'll say, "Hey, here's a Google Meet. You can meet with us here, and you can share a screen and whatever is needed to be done to assure that you're able to get through the assignment." So there will be three people, two including myself, two others, not including myself, that will be working with you, office hours and stuff like that. I have a lot of appointments already set up for this coming week. However, you can schedule for next week, and we can knock out whatever you need help with. So we're going to talk about security architecture and design, but I'm very curious to understand or to hear what information or what new news did you hear last week regarding cybersecurity that you'd like to share with the class?
I guess I can use one of my articles I found.
Sure.
It was one of the articles I read talked about how a founder of a major cryptocurrency foundation got robbed using SIM swapping attack. I believe it was $6 million worth of cryptocurrency.
Oh, that's a lot.
Yeah.
Okay. And then Naeem has his hand up. So Naeem, go ahead.
Sure thing. And I'm sorry, Dr. Mo, if I missed your announcement earlier, if it was pertaining to anything I may have sent.
Oh,
But
you're okay.
I'll talk with you
I was
after.
not. Yeah, I wasn't using names, so I wasn't trying to call anybody out. Now, before you start, I will give people the opportunity to submit for a lesser grade, but that will be afterwards, right? So I don't like to say, all right, well, you have an extra day here, you have an extra 2 days. If you don't meet the deadline, I will provide the ability to submit the assignment for a lesser grade. So you will have that, right? So you're like, oh crap, I missed the deadline. Everything is lost. Everything's not lost, right? So I will provide an opportunity for you to reclaim some points, just not all your points. All right, go ahead, Naeem.
Gotcha. Thank you. So the two articles I actually wrote about in that assignment were regarding, for one, Apple's stance regarding its detection of CSAM and using neural networks to detect that on their iCloud platform at large. And more so, they took a stance against that use. They originally were going to use it, but it recently gained traction again regarding that when the Heat Initiative, a child advocacy group, had come forward to share their disdain for Apple's decision to drop the program outright. And Apple went into great detail regarding how important it was that they not rush out with something that can say scan all the photos in iCloud. Due to the potential risk that could have to consumers and the potential threat avenues that opens up. I compared that with an article from Meta regarding the detection of one of the largest misinformation farms on their platform, going all the way back to 2019, actually, that they were able to find. And I think they got rid of upwards of about 100,000 inauthentic accounts on the Meta's platforms. So those are my two articles regarding that I wrote about.
All right, so Naeem, what's a misinformation forum for those that are unaware?
It was a group that had actually had translated articles with misinformation into 8 different languages, spread them across 10 different social media platforms, and create accounts to spread and essentially influence the algorithm for this information to spread to users to try and attract them and get them, going down an echo chamber and involved in, um, say nefarious conversations and things of that nature, to take them down a certain road or so, and to just spread information that isn't true to different people in different places.
It would be interesting to see a study that actually where people get their news, how likely they're to view that news source. Do they actually do news fact checks? So that would be something interesting. There are some countries that provide I guess a fact checker that will come on the news, like Estonia and some of those closer to Russia. They'll have particular channels and times they say, oh, let's debunk this, and they do that. Here we don't have anything like that. We all know, and I won't say the news station, that we have various news stations that provide half-baked news and facts, and those individuals really believe the full story, and that causes a huge issue, and it's very decisive in terms of dividing people up and stuff like that. So Naeem, what prompted you to look at your last news article?
The last news article was interesting because Meta was the one that reported on it. And what I thought was most interesting was not only necessarily the removal of these accounts and essentially tried to interrupt all efforts from this misinformation campaign across Meta networks, but the implications that something like this has, mainly going forward for the 2024 election, and how misinformation is actually a big concern for a lot of people in social media going forward with the elections. But also how Meta failed to outline any efforts being taken by other social media companies. They made it very clear that this material and this group did manage to get onto other platforms not owned by Meta, such as Twitter, Reddit, YouTube, and so on and so forth. However, they didn't outline any efforts to collaborate with these people. So it kind of left me feeling half satisfied. So the threat's still ongoing, really, and Meta has really kind of half done the job, or really just done the job on their own platforms in terms of getting rid of it, but not everywhere online. And the misinformation likely is probably still spreading right now.
Yeah, and you got to think about what other like I said, what other platforms and ages. You think about like YouTube Kids, that's mainly, I think it's like 11 and below or something like that. What if you have misinformation that spreads there? How impressionable those minds are.
Right,
someone
exactly.
in elementary is not going to go fact check. And then they hear this stuff like, okay, they take it as gospel. They take it as the word, like, oh, wow, this is what's happening. Okay, this person's bad. And they're getting the complete opposite information, or things that they could do. And yet they can mix some materials together and cause some combustion. It's interesting to see how this can cause so much harm, yet what is being put out there is not controlled as much.
Right. I think the reason why I chose these 2 articles in particular was because it wasn't very obvious as to how great some of the threats that both these articles, the actions taken, pose to the public in terms of cybersecurity online. With Apple, for instance, one change in policy could result in a huge privacy issue regarding all iCloud customers and all content saved on their servers. And with Meta, they paint themselves as being the good guys here and taking care of business and keeping people safe, but they fail to acknowledge that a lot of their users use platforms outside of the Meta domain. So what about content there? So I wrote about just how important it was for consumers to keep in mind that both of these articles set very dangerous precedents should something have been slightly different, or yeah.
There's only four certifications that come to my mind that deal with privacy, data privacy. Three of those are really for lawyers and those that work in a legal realm, and only one is technical, and it's the Certified Data Privacy Security Engineer, and that's the only technical one that I know of, and that's brand new. That came out last year through ISACA. So this is a whole new realm. Why I mentioned that cybersecurity, it's very large, but when you think about the tools and the certification certificates for specialized domains, there is some domains there's not any, and privacy engineering is not one of those. That there's a lot of stuff out there, like general cybersecurity. Yes, does it really touch privacy? It touches it. It's a very small amount of information that you're understanding. Maybe you might touch GDPR, you might understand a few laws, but nothing in terms of the architecture of maybe databases and stuff like that for privacy. That's not really in the weeds, the details, data, life cycle for data and stuff like that. So yeah, good article choices. All right. So like I said, this week we're going to talk security architecture design. So we'll talk here, we'll finish up this slides in class, and then we'll also do hands-on stuff. So make sure your VM's ready. We'll go through and do some exercises. And then this Thursday, we'll decide on when do you guys actually want to meet up. And then I would say, hey, this is our particular dates for meeting up and stuff like that. So I will set those. All right, without further ado. So there's a number of computing platforms, and we'll just go through the history. So in the 1930s and 1940s, Dr. Alan Turing, he invented the concept of the Turing machine. That gives us the electromechanical computational machines, ACE, Bombay. And Bombay was used by British cryptologists to decrypt the Germans' Nazis' Enigma machine. Right? This is a very important fact. And especially for those that understand like World War II and what occurred, there's actually a movie about this, right? Has anyone heard of The Imitation Game?
Heard of it, never watched.
Okay, I would recommend if you're gonna, Netflix and chill or binge something, watch The Imitation Game. Please do watch it, because one of the neat things, and it's important, when you discover you break an algorithm, you don't immediately start decrypting everything. Like you decrypt everything, but you don't act on it, because at that point they know that you've broken their encryption. So you have to think about, okay, what's strategic in terms of, I guess answering calls and stuff like that. It's like, okay, well, this is strategic. Let me go to this location because this location needs to be done. However, you will, like in the movie, you'll see that the military suffered some losses because they intentionally didn't act upon the intel that they had. In 1950s, you had Dr. John von Neumann. He wrote The Computer and the Brains, that described a system architecture for the modern microprocessing computing machine. Now, I say this, a lot of these concepts in computing, they're not new concepts, right? 1950s, people, these aren't new concepts. These are older concepts. The thing is that the technology has caught up with the concepts, right? Same thing with like service-oriented architecture. Old concept, later it was able to be done because the technology caught up with the concept. This is MITRE Sage Machine. MITRE is an important organization. They maintain the CVEs, CWEs, and stuff like that. When we get into the actual part where we talk about software security, you will be able to see more what MITRE does and stuff like that. But this is the semi-automatic ground environment machine. Later, you have the transistor computers. This is the IBM 7000 series. Then you have the integrated circuit or microprocessor. And so in the late 50s, TI, or Texas Instruments, it was invented by Jack Kirby of TI. And then you had Robert Noyce of Fairchild Semiconductor. And they were the ones that invented the IC. Later, you go to electromechanical. Here it talks about electromechanical computing machines and the microprocessor computing machines. And you can see here, now you have large scale integration. This is IBM System 360 and the PDP-11. You can see these machines. You can see how large these machines are. When you think about the actual mobile device today, it is an extremely powerful device. Many of us don't even actually use our mobile device to its full limits, right? We barely use our mobile devices. The mobile device is extremely powerful. When you think about, these devices are more powerful than these older machines and what these older machines could accomplish. These are the hardware components. You have the CPU, you have the memory, you have I/O devices, and you have storage. So with the CPU, you have your registers, you have your ALU, which is your arithmetic logical unit, memory, primary and secondary cache. You have read-only memory, random access memory, flash memory, and your virtual memory, which is storage. With the I/O devices, you have your NIC, which is your network interface card, USB, PCMIA, serial, parallel, system bus, and channels. And then for storage, there's a lot of different types of storage: disk, tape, flash, USB drives, micro SD drives. You have a lot of storage, different types of storage that's available. Now, here is talking about different software components. You have your operating system. There's many different types of operating systems. With Linux, you have over 400 variations of the Linux distribution, whether it's Debian, Slackware, Red Hat Package Manager, RPM. There's numerous types of Linux distributions. Then you have firmware, your BIOS, your device firmware, I/O controllers, system programming applications, so your file management systems, network management, process management. With Linux, one of the cool things is that you can replace, update, and change a lot of these things in yourself. We'll do that stuff when we actually harden the virtual machine. Mobile code, JVMs, ActiveX, application macros, and data memory addressing. You have the register, direct, absolute, index, implied, and memory protection. Here is just showing Android architecture. You can see in the bottom, you have your Linux kernel, you have your different drivers, camera, Wi-Fi, keypad, display, audio. On top of that, you have your libraries, Surface Manager, OpenGL, SSL, secure socket layer, FreeType, SQLite, and then you have Android runtime running as well. So you have your core libraries, and then your Dalvik virtual machine. On top of that, you have your application framework, package manager, content providers, view system, location manager, and then above that, you have your actual applications, home, contacts, phone, browser, and what other applications available. But this just shows the software components in a Android architecture. Now, quick question. For those who are running a Android device, do you ever use your device as a desktop? Do you ever dock your device? All right. And if you haven't docked your device, why haven't you tried docking your device and using your device as your actual complete computing platform? All right, it's quiet. Let me hear a response. Why haven't you docked your mobile device and used that as your actual computing device?
I don't think a phone would have enough power.
All right. Well, the phone would have enough power. There's actual systems that, well, I guess you call them docking stations, that you can actually dock your device, right? So for myself, of course, I'm running Android, obviously. I can dock it. I can use it just as a desktop. You can change your device. If you want to plug it to your TV, you can dock it and use your TV screen for your device, get a wireless keyboard, and use your device just as a as a computing, as a, you know, like a desktop or something like that. For anybody here that does the simulators, right? You have the simulators or retro simulators, retro handhelds. Those are pretty much mobile devices that they're using for gaming. You can play with the PS2, I think now even PS3 on these retro handhelds. Just pretty powerful. So you can do quite a bit. And remember, there's different flavors, right? There's damn small Linux, which runs on bare bones. You could run something like that. You could run even Ubuntu had a flavor that you could actually run on your mobile device and dock and use that. And Naeem, you had your hand up. So what was your comment?
Oh yeah, so I was saying I did use Samsung Dex, I think one time when I had a Note 9. But the reason why I didn't really use it as a primary computing platform, probably because I was just settled with my main primary devices already. And I kind of thought it was a cute niche, but I didn't really feel like I want to invest time to learn the ins and outs of using it to be productive for like more than like maybe a few minutes at a time.
Okay. What I'm going to do, I'm actually going to show you guys how a docked device looks. And I'm going to show you guys how it looks. I'll make that one of our labs, you know, showing how the dock device looks, how to do it, how to set it up. So you can take full advantage of your actual mobile device. All right, so jumping to the operating system, we will cover this a lot. Subject, object in the middle with the reference monitor and auditing of transactions. Remember, with the OS, you have user identification, authentication, two types of control: discretionary access control, mandatory access control, and then this is both the OS should mediate transactions, right? Mediate transactions, object reuse protection, so preventing leakage, accountability, so auditing security events, protection of audit logs, trusted path, so protection of critical operations, and intrusion detection, right? So patterns, analysis, recognition. There are additional applications that you can add to provide further, I guess, coverage. And we'll go through some of those like Tripwire, but provide further coverage that is far beyond what is provided just with the operating system. Now, with that said, with what the operating system does, you can actually script something up so that the operating system has those additional administrative features or in security and enhanced security. So you can do that. There are different flavors. One of the labs, what I'm going to do is going to be pretty interesting. I'm going to have you guys use different Linux operating systems so you can see the difference, right? If you run Kali, you'll understand that Kali has a number of tools that you can use, but there's other distributions of Linux for being anonymous, like Tails. There's like security enhanced Linux. There's older distributions of like even Fedora that come with security tools and other things you can do. So we'll go through and we'll see how all these items work and how they look and what you can do and stuff like that. All right, so this deals with OS product scheduling. So multi-programming, so managing and coordinating the process operations to multiple sets of program instructions. Multitasking, this basically lets a user run multiple programs. And the examples they give is Windows 2000, Linux. Multi-threading, managing the processes that managing the process operations by execution threads using the same program instructions. And then multiprocessing, managing and coordinating the process operations in multiple sets of program instructions and multiple user requests using multiple CPUs. So here showing CPU threads, just saying that in today's programs are comprised of individual modules, programs or processes that are separately written and work together to fulfill the overall objective of the application. And those particular modules are called processing threads. Different modes and processing states. Kernel mode, that is privileged. So basically the program can access the entire system. In Linux, how do you get to kernel mode? How do you get to kernel mode in Linux? All right. Please do not be shy. You can type or you can talk. How do you get to kernel mode in Linux?
I know Nicholas just said I was gonna suggest a
Sudo.
super user position.
Correct.
Sorry.
Correct. Yeah. So you have super user and you have user mode, which is none privilege. Why is it important to have different modes of operation?
So to keep a principle of least privilege.
Okay. What is principle least privilege?
It means you don't want the person who, like, you don't want everybody having access to like all functions on on any system. Like for example, like when it comes to databases, you don't want like people who like certain people. You just want certain people to just view the database. You don't want them to be able to edit it or anything like that.
Correct. Yeah,
And
I mean, you go ahead. I'm sorry.
Oh, and by using and that's why like it's kept like that, so that way, for example, if like assuming someone like you set up a computer and like you have like family members on it, you don't want them messing around with the root files or anything. So that's why it's kept separate.
Yeah. So imagine you let someone use your computer, right? You don't want someone using your computer just deleting stuff and things of that particular nature. You want them to be able to say this, the system to say, hey, you want to delete this particular application or install this? You need permission. You need permission to make sure you have those rights to do that, because you could ultimately do something that could mess it up. And Christian says root is not kernel mode. Christian, elaborate.
Root is you're basically running privileged like inside user mode, whereas kernel mode is just kind of completely separate. Like you can make system calls to the kernel, but like I'm pretty sure this is related to like CPU stuff. And I just looked it up, and like apparently, yeah, there's a big difference between sudo and kernel mode, because like you're actually like still in user mode. You're not actually in kernel mode as a root user.
Yeah.
You're just
And
privileged.
also in kernel mode, you can access any memory or any instruction as well. So you have different modes, but then you also still have like, I guess it's interesting. So you have your modes, and you can access information, stuff like that. However, when you think about just the operating system in general, you still have like root and you have your regular user. It's just that like in root, it's not like you can access this right here. They're talking about different states, right? Can you access memory, stuff like that? You can do that in kernel mode. But you can also think of it like as personally, I think of it like as a super user. Like in that particular mode, you can access these items that you can't do as just a user. Was that confusing?
I mean, yeah, I guess. But I mean, I already kind of get this from, past experience and stuff.
Okay. You have different processing states, stop versus run, wait versus sleep, mask, interruptible states. You have different processing states. What I'm going to do here is I'm going to, all right, go here. So this right here shows paging and swapping. And so what it shows is the application accessing the memory manager. The memory manager is going to a page table, and then from there you can see the frames that are swapped. And then it's here, S3 is showing the swap space on the hard drive. And then this is just showing paging and swapping. So application requests access memory. Manager looks at which segments are allocated to that process. The access the memory frame or the process, and it returns the data that's held in memory. Here is showing I/O controllers, just responsible for moving data in and out of memory. An element of managing I/O controllers and thus managing memory is swapping or paging. Here we're showing a number of storage devices. There are, again, this is an older slide, there's definitely some newer ones. Different types of hard disks. You have solid state, you have your traditional hard drives, USB drives. What you see here is an iron key. The iron key is kind of important because the iron key will have SIPS compliant cryptography, encryption. And what that means is if you could place the password so many times, it will actually wipe the device. SD micro memory sticks. these are interesting because you can actually boot an entire operating system based off an SD memory card or a micro SD card. Now, I always say the thing that is, I guess what are you saying? The thing that I guess in terms of security dealing with these micro SD cards is that if they're doing something nefarious, all one has to do is swallow it. It's not like it's something that you can get back.
A quick question.
Yes.
Would tape storage fit into this like section?
Yeah, any type of storage would.
Okay, because I've heard like there's some new like people are starting to go back to some tape storage for certain usage, and I was wondering.
Yeah, so I mean, so some of the storage is better in terms of I guess not auditing, but keeping records and stuff like that, or cost. You know, everybody wants to do cloud, but what is the cost of doing cloud? If that's an issue as well. How, I guess you can say, I don't know if the word would be durable, but maybe how durable or you know, what would be the likelihood of something being corrupted in a particular device, right? So these are all things to think about. And cost is a driving factor. We'll get to a point where we talk about different sites and what it takes to set up like hot sites, warm sites, cold sites, and mirror site. You'll see that it varies in price, but then you have to think about, okay, well, I want to have the site set up. How do I store my items? And so those things are extremely important to organizations when you're thinking about cost, right? So you're not going to, you may not store things on like a USB, right? You may store very small things. USB is not going to allow you to really store things. However, you could have a number of machines that may run off, I don't know, maybe it could be set up where you're using USB to maybe run a device, right? You say, I'm going to load this USB to load up this particular system because I'm just using this as a terminal. It all depends on the use of your machine and what requirement you have to save or archive these items. All right, so let me read through the comments here. And let's see. All right, so I see some direct comments. Would you like me to respond to the class or get back to you with these direct comments? Okay, I'll wait till you say something and then we'll cover that. Okay. All right, so let me go through this. So I get asked the difference between PCIe and flash drives. The biggest thing is just, just think about the pen, right? There's different pens. That's a big thing. So different pens. And PCMA is not really, it's not really used that much anymore. So I would say flash drives, even with flash drives, you have different connectors. You have flash drives that use, you have USB, then your Type-C. So you have those. And I think that's all we can go. Sorry, I'm just going through. Okay, and there's an item about swap space. So basically, it's used to extend the memory available to processors. All right, so I have those. And then someone said something earlier about physical storage to justify it. They never have physical storage to justify it. I'm trying to remember what that's in reference to, but when we were talking earlier about different types of storage, you will perhaps need to have the physical storage to justify it. It just may be safer, right? Because then you'll just pay someone else to manage that cloud. And then additionally, you could take that offline, have it placed, stored somewhere, depending the type of, I guess, data classification. There may be other procedures or processes that you may have to do because of the actual classification of the data that's stored in that medium. All right. There's different models. Graham-Denning model. You have the information flow model, the state machine model, and the interference model. So Graham-Denning is a formal set of protection rules. Information flow demonstrates data flows, communication channels, security controls. State machine, abstract math model, where the state variable represent the system state, and then non-interference, a subset of the information flow that prevents subjects operating in one domain from affecting each other in violation of security policy. So here's just saying compartmentalize. When you think compartmentalize, this is when you're thinking like, I think I mentioned earlier, but if you're thinking government, special access programs, this is compartmentalized information, this would be compartmentalized. So perhaps there are both on a medium level, but there's different compartments of information that's on that level, right? So this is maybe crypto, this is some other special access program. They're all compartmentalized within that same security level, right? So now you have to think about how to make sure that there's no violation of the security policy of that other information. All right. Subject requests service, the object provides that service. And then the security model is the rules of behavior for a system. Access, flow information between a subject and its objects. Access capability is what a subject can do to an object. Again, you have two different types of access control, and there's more than that, but here it shows discretionary, mandatory, think of confidentiality or classification. Here is showing Graham-Denning's, and it's showing that it is an information access model that operates on a set of subjects, objects, and rights. So you have levels of protection all the way to no sharing to providing certified subsystems and operations, creating an object, deleting an object, reading an object, things that you can do with the object, read, write, access, right? This is the Harrison-Russo-Ullman security model. It's just the access capability matrix. It's all it is, right? What a subject can do to an object. So subject one can control subject one, but in terms of object two, it can only read and write. That is all this right here is showing. Information flow illustrates the direction of flow between objects. It's based on security levels. The flow is constrained in accordance to the object security attributes. And then here it just says covert channel analysis simplified. We go to Bellapagio security model. This deals with confidential only. And it's easier just to go here. So when you look here, there's three different properties. Simple security property, the subject cannot read an object of higher sensitivity. You have the star property, subject cannot write to an object of lower sensitivity. And then the strong star property, that the subject cannot read, write to an object of higher, lower sensitivity. All right, so simple security property. So again, Alfred has a secret clearance, like his clearance is secret. He's been cleared to see secret. Object B is secret. Object C is confidential, and object A is top secret. So someone explain to me why Alfred can only read object B and C.
Because Alfred may obtain sensitive information that he's not supposed to know, and he could like leak it to a website.
Not for this one, but think about it. So you've been cleared for secret, right? You can only see stuff at your classification and lower. Why can't you see something that's at a higher classification?
You don't have the proper clearance to even see that information.
Daniela, you are on the money. I mean, I don't have money to give you, but it's just a saying. But yes, Daniela is correct. It's simple as that. You don't have the clearance. You've been cleared for a secret. Why should you see something that's above you? You just don't have the clearance. All right, the next one. So you just did read. Now we're going to do write. So Alfred, he can read. He can write to secret. He can write the top secret, but he can't write the confidential. Someone other than Daniela, tell me why Alfred cannot write the object C?
If you write secret information to the confidential object, then the secret information is at a confidential security level, and then it could possibly, get leaked, or like everything else in the object would have to be raised as secret now that it contains secret information.
Question that the U.S. government wants you to serve. Okay, just gonna let you know that. That was good. You are correct. Yeah. So imagine you're looking at an object that's unclassified, right? You can read it, but now all the information that you can see at a higher level, you're beginning to write that at a lower object. And now object C is now to be treated as secret. Now imagine if you write something here that could be top secret. Now that item that has the security controls of something that's unclassified has to immediately comply with something that's top secret. You could change the classification of just a standalone machine or an entire enterprise based upon putting data in there that was never meant to be in there. It's a huge issue, right? Now, what's interesting is Alfred can write the top secret, but he can't read the top secret. Someone explain that to me.
It might be it's not just his work, but work of others as well. Like for example, using like GitHub as an example, like multiple people can write to a GitHub, like each working on a different section of the project. And it would be better if not, and it might be better if not everyone knows exactly what the other is working on.
Yeah, something like that. Plus, there's something called a security classification guide, and that particular guide can say what phrases or what technologies are classified at what level. So they may not know that they're writing something top secret, or they're writing something and describing something that has to get a higher classification. So they may not even know that, right? So you have that. Plus, sometimes when you place data, maybe two pieces of secret information together, it is now top secret. So it depends on an SCGA, because there's a different combination of stuff that can raise security level of that particular document or program or that system in general. All right, now we go to the last one, which is strong property. So Alfred can only read and write to secret. Why can Alfred only read and write to secret? All right, but yep, okay. Object A is a lower sensitivity, but there's more than that. So they can only read and write the object B. So you have object A, you have object C. Why can he only read write to that particular object? Well, you have that. So object C could be leaked, but to make things simpler, he only has clearance to fully read and write to an object, and that's B, right? So the previous ones was just what can he read, what can he write, and when you look at that, right, you look at the first two, the simple security property, star property, Alfred can only read. I mean, the only one that he can read object B and C, but he can only write to object A and B. But when you think about it, he can't read object A. And the last one says, what can that particular subject do? It's only B that they can fully read and write. Just simple as that, right? That's all it is. Now, again, this particular bill of module is based on confidentiality. It's based on security tags or classifications. All right, yeah, the BIBA security model is the state machine model, and it is for information flow and integrity control, and it addresses integrity information system. It's based on hierarchy lattice of integrity levels, and there's a number of elements. So you have set of subjects, active information processing. You have set of subjects, passive information repository. In terms of integrity, preventing unauthorized subjects from modifying objects. And it has a mathematical dual of access control policy. And here is showing the BIBA simple security condition. Subject cannot read objects of lesser integrity. So lesser integrity, they can't read objects of lesser integrity. And then they cannot write to objects of higher integrity. So if there's a higher integrity, they can't write to the object, right? And then you have the invocation property where these subjects cannot send messages to objects of higher integrity. Right, so they can't read objects of lower integrity, but they can read objects of in their level or higher. Again, this deals with integrity, it doesn't deal with confidentiality. So when we look at the Bellapagio model that dealt with data classification, this one deals with data integrity. Very different. All right, Clark-Wilson. This one is a state machine model that addresses information flow and integrity goals of preventing unauthorized subjects from modifying objects, preventing authorized subjects from making improper modification of objects, and maintaining internal and external consistency, right? So when you look down at the bottom, it shows subject objects. The subject cannot directly interact with the object. What this means, it means that the subject must go through a program to have any interaction with the object. And what you saw early in the earlier slides was showing the different particular models that can be used. All right, so here shows the Clark-Wilson model. So here there are certification rules, and it also shows enforcement rules. So certification rules, there's 5 of them, but if you look at the C1, when an integrity verification procedure is run, it must ensure that all constrained data items are in a valid state. The enforcement rule, the system must contain the certified relations and must ensure that the only transformation processes certified to run on a constrained data item manipulate that CDI. What happens with these particular models is that you have a number of rules and enforcement rules that must occur. And again, these are the things that, as a, I guess you could say, the architect, you'll decide, all right, oh, I need to make sure these particular models will work on my system, or depending upon what you need to be compliant with, a particular model will work better than the other. All right, Brewer-Nash is a simple Chinese wall. This just protects in terms of conflict of interest. It's the Brewer-Nash model. You have the subject and you have 2 clients. So the particular, you're working for client alpha. You can only see client alpha's information, and you're walled off from seeing client beta. This may occur if you're part of the company actually trying to acquire a particular product, but you're already building that product internally. Then you can only, and you're working on that product, then you can only see client A, right? You can only see project A. Project B, you can't see. You have no clue what's going on. Or if you're doing consulting and you have 2 clients that you're providing services to, and maybe those clients are competing, you may have to sign a conflict of interest, or what's known as a proprietary information exchange agreement, a PAEA agreement. Same thing. It just ensures that particular organization's information is kept proprietary, and you're not in a I guess position to even leak that information. So that's why you have the Chinese wall. Non-interference model is loosely based on the information model. However, it focuses on a number of things, right? It focuses on how subjects at a higher sensitivity level affect the system state or actions of a subject at a lower sensitivity level. All right, so here you can see a non-interference policy, but here it just shows high, low, and it focuses on the actual how it affects. What's interesting here It just says with assertion of the non-interference security policy, the non-interference model can express a multi-level security capability passing confident confinement, compartmentalization, discretionary access, multi-user, multi-key access, automatic distribution, and authorization chains and downgrading. There's MILS, which is multiple independent level security. There's multiple single level security. And those deals with the implementation of a particular system and how data flows through. But a true MLS system is one system that has low, medium, high data all running through the system and allows different users to sign into the machine as well. And everything is tagged so data does not get sorry, hiccup there, does not get corrupted or with other data classifications. So a true MLS system, there's not many that do that. There's a few, and when we talk about Carbon Criteria, I'll pull up some that are that have been certified through Carbon Criteria. But this right here really deals with MLS and the implementation of MLS. A lot of times now, well, years ago, what you will see hardware software solutions. General Dynamics had a product called the Trusted. It was the trusted security operating system. It was a Sensler system that was certified by the Communication Electronic Security Group out of the UK that allowed individuals to do everything from unclassified to top secret. All right, rule set based access control model. This is a access based on a set of rules that determine capabilities. What's interesting is I mentioned mandatory, I mentioned mandatory, I mentioned discretionary. There's rule-based and there's role-based. Role-based is simply based on a particular position. Let's say someone's a system admin, they have access controls based on that. Rule-based or rule set, think about having access. The easy way to implement rule set or rule-based is individuals charging to a particular work account, they get access, right? They get access to that particular folder or system. And then once they stop charging, then they're cut off from that. But you have to think about what rule set makes sense in implementing this access control. With this, what you may have to do is implement role-based, then rule-based, so things work, I guess, a little bit more better. All right, different evaluation criteria. So you have Orange Book, you have the UK confidence levels, German criteria, French criteria. Those particular criteria, you can see they're all different, right? The problem with having all that's including, look at Canadian, federal, ITSEC, then finally you have what the Carbon Criteria is right now in the late 90s, is that a lot of these particular countries were operating on different guidelines for protecting information. The issue is when you think about these countries, they're NATO countries. When they're working in a NATO environment, not all systems are protected the same, which means an individual would or should attack a weaker country or a country that doesn't have as stringent cybersecurity controls in place to gain access to the rest of the system. So here it just says that the trusted computer system evaluation criteria evaluated confidentiality only. Now, the IT security evaluation criteria, or ITSEC, evaluated the entire triad. And then Carbon Criteria provided a common structure and language amongst a number of countries that get to certifying and then those that are consuming. And it provided an actual international standard. So it's ISO standard 15408. Okay. So again, we'll cover Carbon Criteria a bit. What I'll do is I'll show you the site later on and you can see how detailed the Carbon Criteria is. All right, again, all of these, there's different requirements for every particular item here. So security policy, either discretionary or mandatory. Again, there's more than DAC and MAC. Rule set, rule base, marking labels, these are sensitivity labels. What's interesting, NATO actually has a common language for marking of objects. Before, different countries had different markings of sensitivity levels, which create an issue when you're in an environment, a joint environment, you're trying to share information back and forth. They're like, wait a minute, this is secret. in my country, but in your country, it's top secret. So now they have NATO secret, NATO unclass, and stuff like that. Identification of subjects. So identification and authorization of users. Audit logs. Based upon the classification of data, logs may have to be kept 3 or 1 year. That's from a government standpoint. In the civilian sector, they may have to be kept even longer, or there may be more stringent items placed of these logs. Maybe the logs are captured and they're getting hashes of each log. So in the future, if someone has to go to court, they can say, hey, we have this chain of custody, and these are the signatures, these are the hashes associated with these particular logs, so they can defend, like, these are the logs, this is what happened at these dates, and here's the hash for it. Then you have assurance. These are just the operational security requirements. So basically assurance and meeting the policy, marking, identification, and accountability requirements. Documentation, security features, user's guide, the trusted facility manual, test and design documents, and then continuous protection. Continuous protection is just anti-tamper. Anti-tamper means if you open the system up, it's rendered useless or you know it's been tampered with. I always use consoles because for those that are gamers, everybody knows you can remove the actual stickers with a heat gun or a blow dryer, remove the stickers, replace them, and no one knows it's been tampered with. However, if you were to open the system and all of a sudden the system is rendered useless, then you have what's known as active anti-tamper. There's actually a document that covers the anti-tamper process. There's an entire accreditation, certification, and accreditation process for active anti-tamper as well. That's maintained by the Air Force, and they have an entire process of actually implementing anti-tamper. All right, again, I'm just going to breeze through these. There's tons of divisions. These are all the divisions with this particular item here with the trusted computer system evaluation criteria. You can see it goes from minimal all the way to verified design. Right? Again, these all change, right? Here it just says, in terms of the criteria, the objectives say why is the functionality wanted, and then what is actually being done, and then how it's being done. So you have your objectives, your functions, and assurance. Now, where it says target evaluation, this particular target evaluation or TOE is this language is used in the Karma criteria. In the Karma criteria, you have protection profile, security target evaluation. These particular artifacts are used and the language. So like security function says required evaluation level. In the Karma criteria, you have EAL, which is evaluated assurance level, EAL 1 through 7. 1 through 4 is that's transferable by anybody within the, it's transferable by anybody that's within the Karma criteria using it. However, if it's 4+, meaning it's a requirement, it comes out of 5. Only that country's national security agency can evaluate the particular product. Again, it shows the various ratings. So you can see here, mirrored functionality aspects of the Orange Book. That C1 through FB3 is showing this one. But when you get to F10, high confidentiality and integrity requirements for data communications. You can see that there's a whole lot more stringent requirements that are placed, right? A lot more difficult. You look at E0, inadequate assurance, E1, system and development, E6, formal end-to-end security tests, and source code reviews. And this is what I talked about earlier in terms of there were discrepancies between these particular criteria. You look at IDSEC, it goes all the way to F10, but when you go here and you look at the one on the right, it stops at A1, so you're missing 1 to 5 particular ratings, right? It stops here. So A1 is the equivalent of B3 E6. It stops there. So imagine you're in a joint environment and you have countries that are using different ratings for their system. It creates a big issue. Now, there's the protection profile, ISO 15408. Remember I mentioned there's 3 different things, 3 artifacts. Protection profile, the TOE, the security target, and then again, you have the EAL. So protection profile, specific functional and assurance requirements, applies to a category of products, not just a single one. Then you have the target evaluation. This is the specific product or system that's being evaluated. Then a security target is written by the vendor or developer to explain functional and assurance specifications of the product and how they'll meet the karma criteria or the protection profile requirements. And then EAL, this gets assigned. So here, part 1. So you see protection profile, TOW, security target, functional and assurance requirements. So requirements could be the system shall have encryption, and then how are you going to meet that? You know, these particular subsystems or systems of CSCIs or CIs will use this level of encryption for this, right? You have your evaluation and then your EOL is assigned. All right, one moment. All right, protection profile is an implementation independent specification, has the objectives, functional requirements, the assurance requirements, and assumption and rationale. And everything here for the protection profile is laid out here. Security target is very similar to what we just seen previously. The same items, but basically this is vendor response to the protection profile. Then you have the TOW, and this is the specific product or system that's being evaluated. And you can see right here what the EALs are. EAL level 1 is being functionally tested, then structurally tested. You go to EAL level 6, semi-formally verified, designed, and tested, and then formally verified, designed, and tested. And here it says the U.S. recognized products that have been evaluated under the sponsorship of other signatories. These are basically the security agencies in other countries, in accordance with the International Common Criteria for Information Technology Security Evaluation Recognition Arrangement, this is the CCRA, for EALs 1 through 4 only. If you have one requirement that's outside EAL 1 through 4, because you don't necessarily have to go EAL 5, you can do EAL 4 plus, then that particular evaluation needs to happen in this country by the National Security Agency. All right, so what I'm going to do now, I'm going to pause this. I'm going to stop here, and I'm going to bring up something else. So let's, and I'm going to bring up something I want you guys to, I'll share it. We don't have much time left. Criteria. So what I'm going to do is I'm going to just share this portal. Let me do this. All right, so what you should see now is the Karma Criteria portal. And I'm going to provide you guys the link right now. All right, so I just sent you the link. And we don't have much time left in class, but what I want you to do is spend the next 10 minutes going through this. And I want you to get familiar with this a bit. See kind of, what products are out there. You can take a look at the TOWs, protection profiles, and all that stuff. What's interesting, these are the countries that are certifying members, right? Then these are countries that are certificate consuming members. So what you'll do is you'll look at certified products. And you can say, okay, I'm going to look at operating systems. Okay, you can see there's a lot of products here, operating systems. And I'll show operating system, and I'll show the scheme. This is the actual organization that probably certified it, obviously. The CCRA certificate. So spend time, go through this. And then any questions you can ask me, and I'll provide answers in the meantime before class is out. So for the group assignments, what I will do, I will go in discussion board and I will provide some of these, there's already discussion boards that create groups. But you'll go on a discussion board, you'll create a group, and then you'll use that as a form of, communicating and stuff like that. And you can take it offline. You can, develop your shared drive, put your artifacts in there, and make sure that everyone can go in there. They have access to edit, and that will work. That will be a way for you to communicate. So does anyone have any questions? Oh, Mohammed, you're going to make the group. Yes, each assignment states what are the limits for the groups. And so generally the assignments will state no more than X amount of students. Mohammed, is not a big deal. Like everybody needs a group. So I would just post, hey, I'm Mohammed, looking for a group, and then people will join your group because everyone needs a group. So I wouldn't even worry about knowing anyone. That is kind of one of the good things about the groups. Like you don't have to know anybody. Like everyone needs to get the assignment done. So you just say, hey, here I am. I'm starting a group, and then you can use that. That's why you have the discussion where to use that to, gather your group. No worries. And then if you have issues with your groups, the GRAs will work with you to make sure you get in a group because everyone will be in a group. And if there happens to be some odd number, I will increase some groups to accommodate accordingly. And remember, for class this week, make sure you have your virtual machines up and running because we are going to do some nifty exercises. And then also for our labs, have your virtual machine up and running. And the other thing that you can do is you can let me know what particular projects that you like to talk about on these Sunday chats because maybe there's something outside of the scope of this class that you want to talk about as loosely related. We will do that as well. So I've had some particular chats where maybe like 10 students like, hey, I have a question. I want to do X, Y, Z. How would I go about that? And we walk through that particular scenario. Michael, I see your mic's up. You have a question.
Yeah, this was about the previous assignment. While trying to submit it, I found that Blackboard doesn't accept SH files or .sh files. I was wondering, like, is there a format we should use for it instead?
Oh no, you put it in a zip folder. You zip everything out. You can just zip it up and then upload it.
Oh, okay.
I was going to suggest the same thing. That's what I was able to do.
Yeah, trust me, I'm always in trouble with the director of security for the actual IT office. He called me the other day and said, Mo, during the summer, I get calls every day about your labs. So yeah, you just do it that way. Yeah, so I mean, they're worried about the university gets worried about certain files that could potentially, damage the network and stuff like that. So you just zip it. That's all it is.
It's okay for this first assignment. Like I put it in a doc because I wasn't sure exactly what to do.
Like
I put
when
the
I
source
reopen
code.
when I reopen to resubmit, you'll take it and put it in an SH and just say, hey, I give you permission to do it since you already provided it before the date. I'll give you permission to like resubmit, and then no points taken off.
Okay, got it.
All right, so in about like 3 minutes, I'm going to stop and ask you guys some questions on what you've seen, what you've learned going through the Karma Criteria site. Yeah, Danielle, you did the same exact thing.
So yeah, just double checking. I just write down like, hey, I'm need to switch these to SH files.
Yeah, just say doc mode, prove this whatever date, boom, that's it.
Okay.
Yeah, so what I'll have to do is look at the actual assignment for network. Because within the assignments, I should state how many people are needed. So let's look here. Yeah, you can write the message as early as you want. All right, so the network assignment says how many students should be in a group. So you can look at that one now and it says it. So all the items they're open, except for the exam or whatever. They're all open. And again, with all these assignments, I will go through each and every single one so you can see how it's done. All right, it's quiet. All right, so we are done. Does anybody have any last words?
Oh, Dr. Mo, just real quickly, should I schedule an office hours appointment with you?
Yeah, let me pause this recording.